now that you know that sequences are not intimidating, moreover, this notation is not intimidating, what we're going to see here is a bunch of formulas. If the sequence A sub n and B sub n are two sequences and C is a real number, we have the following. Okay, this is going to be equal to CA1 plus CA2 plus dot 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 CAN. Okay, yn because this is my last number. Okay, so this is always going to be equal. We can take common factor, which is CA1 plus A2 plus dot 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 AN, and this is going to be equal to C summation from k equals 1 to n of AK. Okay, meaning I can assume that this is equal to this. Okay, in the same way we have that the summation from k equals 1 to n of A sub k plus B sub k is going to be equal to the summation from k equals 1 to AK to n plus the summation of k equals 1 to BK to n. Okay, this is going to be the same. In the same way, the subtraction is going to be the same. K equals 1 to n of AK minus the summation from k equals 1 to n BK. Okay, now you're going to tell me what's up with this weird notation that we have over here. Well, indeed, that one is a little bit weird. Okay, why the assumption here is that j plus 1 is a number greater than 1. Okay, so what you have over here is, this is a little bit crazy. Okay, bear with me. We are not going to use it that much, but well, it's an FYI. K is equal to 1 to k equals n of AK minus, and it's going to be the summation from k equals 1, okay, up to j of AK. Okay, what it means is that this number, okay, this is the whole equation, so the whole sequence. Okay, well, the addition of the sequence. Okay, so I'm taking out some numbers over here. That's what we are doing. Okay, here you need to have a condition where the j needs to be greater than 0 and n it needs to be greater than j. Okay, so this one we don't use it as much, but it's a good FYI. Okay, the last one that we have over here, well, no, it's not the last one. We actually have 4 more. Okay, so the one that we have over here, you have that it's going to be k plus k plus k plus dot 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 k plus c. Excuse me, it's not k. How many times are you going to be adding c? Well, you're going to add c n times. Okay, so you have that this is the same as multiplying n times c. Okay, where you know that where c is a real number. Okay, a real number. Okay, here what are you going to do? Is this the same? No, this is not the same. Why? Because this is k. Okay, so I'm going to plug the 1 here. Okay, because this is k plus 2 plus 3 plus dot 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 up to n. Okay, so this one is different. Okay, so they are different. Why? This is c, which is a constant. This is k, which is the name of my index. That's why it changes. Okay, so for this one, what you have is you have a formula that it's n plus 1, everything divided by 2. Okay, so that's a formula that you have for this type of equations. Okay, so this is a good formula. Now if you have this, okay, this is going to be equal to 1 squared plus 2 squared plus 3 squared plus dot 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 n squared. Okay, this one also has a formula. The formula is going to be n times n plus 1 times 2n plus 1, and everything will be divided by 6. Okay, so that's the formula that you have for the square. Now this one is going to be the cube. The cube is going to be 1 cubed plus 2 cubed plus 3 cubed plus dot 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 n cubed, and this is going to be equal to another formula. It's going to be n times n minus 1, okay, divided by 2, and everything square. Okay, these are formulas that, well, you have over here. Okay, and we're going to use it in a second, but I'm also going to tell you how to use it with the calculator, which is much easier. Okay, so find the sum of each sequence. Okay, and you have the situation, and you're going to tell me, okay, using the properties of the summations that we have over here. Okay, I know that this is a subtraction, so I know that this is the same as k equals 1 to 10 of k squared minus the summation from k equals 1 to 10 of k. Do you agree with that? This is equal to this. Moreover, we have a formula for this one. Okay, what's the formula that you have? This one. Okay, instead of n, what do you have? 10. Okay, so the first one, and I'm going to put a parenthesis so you know that it's the first one. It's going to be 10 times 10 plus 1 times 2 times 10 plus 1, everything divided by 6. Okay, and that's going to be this part. Minus, and then put another part here, and it's going to be this, which is going to be basically this. You're replacing the 10 with the n. Okay, so you have that it's going to be 10 times 10 plus 1, and it's going to be divided by 2, and that's going to be your value. Okay, which is going to be, by the way, I'm running out of space here. Well, let me put it here. Here, 330. Okay, if you do it. Now, the beautiful thing in the calculator, let me show you how to do it with the calculator. Okay, with the calculator, what you're going to do is you go to menu, as usual. Okay, you go to calculus. Okay, here you're going to the sum, and guess what happens? Wow, the summation. Okay, so I'm going to plug everything that I have. In this case, I have that this is going to be k equals 1, and then you have that your maximum upper bound is 10. Here you have a parenthesis that I don't know why I'm putting it again, so you have that it's going to be k squared minus k, and guess what happens when you plug that? Boom, 330. Isn't that nice? So you can do it with your calculator, and with a CX it also works. Okay, so for this one that we have over here, what do you think that we're going to do? Well, you can do it in a lot of ways, right? Okay, so the easiest way that I can think about is this is going to be equal to 5, okay, 1, and then you have 4, and then you have the k, right? And then you could have a negative, and then you have the summation of k equals 1 to 4, and then you have a 1 over here, right? Are we okay with that? So you have that this is going to be equal to 5 times, and this one is going to be the same as this one. The only thing that changes is this is going to be 4, and this is going to be n. Okay, so what do you have here? This is going to be 4 times 5 divided by 2, okay, minus, and how many times are you adding that that 1? Okay, you're adding that 1 4 times. Okay, 1 2 3 4, so you have that this is 4. Okay, when you compute the situation, what do you have? Well, you have that this is going to be 25 times 4 is 100, divided by 2 is 50, minus 4, and this is going to be 46. Are we okay with that? And you're like, well, that's it? Well, indeed, that's it. Okay, of course you can do it with the calculator. Remember, calculate, then you go to calculus. After that, you go to sum. K is equal to 1, and this was 4. Okay, and then you have that it's 5 times k minus 1. Okay, and then you have the 46. Okay, so this one that we have over here, you can just do it with the calculator. Let's do it just with the calculator. You know that you can use the formulas, but I'm just going to do it with the calculator. Remember, menu, calculus, then you have the sum. After that, you have that k equals 1. Then we have that it was 20. After that, you have that it's k squared plus 5k plus 2, and then you have that it's 3960. Okay, that's your answer. Yay. Okay, and so the last example that we have over here, what we're going to do here is we are going to plug it directly in the calculator. Okay, so I go to calculus, sum, after sum you have your k is going to be equal to 5 because 5 was the lower limit here, the upper limit is, or upper bound is 12, and then you have that here is 3 times k to the power of 3. Okay, so you have that, and you have the value which is going to be equal to 17,952, and that's going to be your answer. Okay, so feel free to use a calculator. Okay.